All of them are functions. By the vertical line test, all of them are functions. So this is a function, this is another function, this is another function. So again, we're talking about a new operator that we have not seen before. It's the LIM operator. It's read limit of f of x as x approaches 5 from either side. How will that look from the left and right? I'll show in a minute. So follow my markers. As x approaches 5 from either side, what does the function values, what do the function values do? What are they? Where are they going? What does the function do? What does it do? So as x approaches 5 from either side, the function values will go where? Closer and closer, closer and closer to anyone? Closer and closer to what? Do you see this number? It's not clear? Anyone, please? Julia, do you see this number?
Yeah.
Is it clear?
Yeah.
Okay, so then as x gets closer and closer to 5, the function values get closer and closer to which number? We have to read from the y, right? We read here from the x and we read here from the y, for y. So as x approaches 5 from either side, where will y go, or f of x?
To the 6.
Exactly. So for this first one, we write limit of f of x as x approaches 5 from the right is 6. The limit exists if it is a number. If the limit is not a number, the limit does not exist. Okay, let's look at the second one. So this was for this. Let's look at the second one. As x approaches 3 from either side, the function values, the tendency of the function or the function values get closer and closer, closer and closer to which number? What
4.
From the left of 4.
Oh.
But from the right? So when x approaches 3 from the right, the function values get closer and closer to how much? Maybe you're muted?
5.
Exactly. As x approaches 3 from the left, the function values from the left get closer and closer to
4.
Exactly. So in situation number 1, so this is situation number 1, and this is situation number 2. In situation number 2, we will write the limit of f of x as x approaches 3 from the right. The power is plus, meaning with numbers higher than 3. And you already gave me the answer to be 5. You also said that the limit of f of x as x approaches 3 from the left, power of negative means from numbers lower than 3. You said that this was 4. But now, what will you say for the limit as x approaches 5? I meant 3, of course. 3 from either side. No plus, no minus. Instantaneously. simultaneously from either side of f of x, what will you say? Do you have a number? Do you have a number to give me here? Yes or no?
No.
No. So we say D N E. It stands for it does not exist. The number has to be the same. See here, as x approaches 5 from the left, the function values approach 6. As x approaches 5 from the right, the function values approach 6. That's why this exists. From either side, it exists. Now what about here? I'm going to call this scenario number 3. What will you say about the limit as x approaches 3 from the left? And then the limit as x approaches 3 from the right. So let's do that. As x approaches 3 from the right, the function values do this. Where are they going? What is the tendency of the function as x approaches 3 from the right? Where is the function going? What do I write? From the right, here.
Is it negative infinity?
Excellent. Thank you so much. On the other side, as x approaches 3 from the left, where are the function values going?
Infinity.
Good, awesome, great job. So then what will I say about the limit as x approaches 3 from either side of f of x?
It doesn't exist.
Excellent. Now, one more thing before we look at the examples in the book. A very important situation. What about this? So this is function f of x. I'm going to ask you the limit as x approaches 3 from the left. Limit as x approaches 3 from the right. And then, of course, I'm going to ask the limit of f of x as x approaches 3 from either side. Anyone would like to try? It's okay if you're wrong. Please have the courage to speak up. Please, it's okay.
Yes?
Is it just 6 for x approaching 3?
So careful. Let's do this together. 3 from the left. Function values. How much?
4?
Thank you. 3 from the right.
Is it also 4?
Excellent. From either side. As long as they are the same, we know the answer. We don't have to think.
4.
Very good. Now I'm going to ask something else. F of 3.
6.
That's it. So what is the point I'm making with scenario number 4? The limit may exist even if the function is not defined there, but it's defined somewhere else, or not defined at all. So the tendency does not mean the function value. Understand that these two concepts are different. This says find the function value at 3. It can be 6 or it can be DNE. This one says find the tendency, not the function value, which may or may not be there. Find the tendency. Here is the tendency. As x approaches 3 from either side, this is the tendency, which happens to be totally different than the function value at that point. Okay, so now I'm going to, where are we? Here it is. Where's my, okay, good. So every time I get out of there, it just goes away. Oh no, okay, never mind. So I'm gonna click on anything. I have the page number 112. I hope I'm not logged out. I think I'm not logged out. Okay. So we go to 112. And let's look at a few graphs. Let's choose one and answer questions. So they're giving us the graph for 23 and 24. Here's the graph. It's a piecewise defined function. They already graphed it for us. We don't have to do anything. So the limit of g of x as x approaches 4 from the left. The limit of g of x as x approaches 4 from the left. Can anyone tell us 4 from the left? And then 4 from the right, and then from either side. 4 from the left. What will you say? Anyone, please? Anyone would like to give us an answer? Limit from the left of 4, the right of 4, and either side of 4. What do you think? I can correct if I don't know any answer. If I don't hear any answer, please.
Is the left of 4 2?
So let's take a look. 4 is here. 4 is right here. So the limit from the left of 4 is?
-1.
Awesome. The limit from the right of 4 is? So the left is -1. What about the right? Anyone, please?
Is it -1.5?
But how can it be? This is the point right here, right? This is the point.
Mhm.
The left goes to -1, the right goes to -1. There is no jump, right? It's the same point.
Okay.
If it's from the left or from the right, it doesn't matter. It's the same point. There is no jump like here. So the left-hand side cannot be one number and the right-hand side be a different number. So the left is -1, the right is -1, so the either side is -1. Everyone understands that? Yes? I don't hear anything, so I don't know. Okay, so then if I ask now what is the function value, what would you say at 4? function value at 4 is, you may be muted, maybe you're saying something, but I don't hear you. Can anyone give us the f or g of 4? Anyone?
-1.
Of course. Awesome. It happens that in this particular case, the function value and the limits are all the same and they all equal -1. Awesome. Brilliant. Thank you. Now let's answer 24. The limit from the left of -2. Can anyone give us the limit from the left of -2?
Four.
Excellent. The limit from the right of -2.
2.
2. The limit from either side of -2.
Does not exist.
Exactly. And also I would like to ask, what is the function value at -2? Which is a totally different concept.
2.
Excellent. Thank you. Thank you. Thank you. Moving on. Okay. I'm going to ask here the limit of the left-hand side of -3 for this graph. Left-hand side of -3, the limit is?
Infinity.
Excellent. The limit, so as x approaches -3 from the left, the function values go to infinity. Awesome. The limit from the right of -3, as x approaches -3 from the right, where do you see the function values go?
-infinity.
-infinity.
Awesome. And then from either side of -3, what will you say? If we want to determine the limit, this one. The limit
Does
from,
not exist.
exactly, because they're not the same. Even if they are the same, okay, but they are not numbers. So situation 5. In situation 5, I could also have this. And both sides go to infinity. So this is 3. So here's the limit of f of x as x approaches 3. This should be written as dne. No, we do not write dne, although it does not exist because it's not a number. But because both sides go to infinity, we have to write infinity. But this is actually correct. If it's a symbol, the limit does not exist. But we cannot write dne in this situation. We have to write infinity. Okay, perfect. Great job. Okay. Do we understand the concept of the limit? What is the concept of the limit? It's very simple. The tendency, where the function values are going. So for example here, this is a US Postal Services situation. So let's do just one question. The limit from the left of 2, look at the graph, and give us the limit from the left of 2. The limit from the left of 2.
(1.21).
Excellent. As x approaches 2 from the left, the function values get closer and closer to 1.21. 2 from the right. As x approaches 2 from the right, the function 1.42. And the limit, of course, the limit from either side is unquestionably does not exist. They're not the same. Okay, good. I know I only have 5 minutes left, but I'd like to use them efficiently. So in section 1.2, we're going to talk about these were graphs. We try to understand what this operator is all about. But now we're going to look at algebraic limits. So this was with graphs, but the algebraic limits. So if we look at the limit as x approaches 2 of a polynomial function. Can anyone give us a polynomial function? Degree 1, 2, 3, whatever you want, any polynomial function. So we can determine the limit when x approaches 2. Any polynomial function. Anyone? Anyone, please? Okay, I'm going to say 2x plus 1. Because this is a polynomial, all we need to do is just plug it in. Plug it in. Plug in for polynomials. Can anyone give us the limit? We don't have to graph. If the limit is determined from a polynomial function, all we have to do is plug it in and give me the answer. Can anyone tell us the answer? Please, anyone?
So would it be -2 times 2 plus
Yes,
1?
exactly. What is it? Excellent. Yes, that's it.
Maybe like 5?
So let's try again.
Sorry. Would it just be 1?
Let's try again.
-3.
Good. So -2 times 2 is -4. -4 plus 1 is -3. This is it. Awesome. Now, when we have a situation like this, a different function, of course, x approaches 4, let's say from x minus 1 over x plus 3. Because 4 is 4 in the domain, that's why we discussed domain. Is 4 in the domain of this function?
No.
Does it make the denominator 0? If it makes the denominator 0, then it's not in the domain. But if it does not make the denominator 0, then it is in the domain. Does 4 make the denominator 0?
No.
No. So it is in the domain. If it is in the domain, plug it in. Plug it in if 4 is in the domain. If it is not in the domain, something very special happens. Can anyone give us the limit then? Because 4 is in the domain of this function, what would you say as the limit for this function, for this rational function? Anyone? Please?
3/7.
Yes, 3/7. I'll stop. I will not have time to discuss the next one. So if I have limit as x approaches 0 from 1 over x, 0 is not in the domain. So there is a totally different discussion here. This is the starting point on Thursday. So what we learned quickly from 1.2, which you cannot finish, but you can finish 1.1. We learned that if we determine the limit of a polynomial, very easy, plug it in. If we determine the limit of a rational function when x approaches a number that is in the domain of the function, again, plug it in. But if x approaches a number that is not in the domain of the function, this cannot be 0, then we have to discuss on Thursday, and that's our starting point.